Hello students. In this video we're gonna take a look at the multidimensional arrays, and in particular we're gonna look at the two-dimensional arrays. We're not gonna look at the 3 or 4 or 5 or n-dimensional arrays because they are not that easy to represent, but for two-dimensional arrays we can represent that on a piece of paper as a matrix, as a grid. Okay, so basically a two-dimensional array, you can think of that as a grid where the rows are actually the with rows and columns. So to declare a matrix, to declare a two-dimensional array, what you have to do is to type in the type of the two-dimensional array and then the name. I'm gonna call that matrix, and then I'm gonna give it how many rows does it contain. Let's say it contains 5 rows, and then how many columns. So every row has a bunch of columns. How many columns every row has. So I'm gonna make it 4. Okay, so it's an array that has 5 rows and 4 columns. It's a matrix, it's a grid. Alright, so to access, for example, the top leftmost element, all you have to do is to type in the name of the array, the name of the matrix, and then the indices of that point. So it's 0, 0. So the first parameter here stands for the, let's say it's the row index, and the second value is the column index. So we're talking about the cell that has row 0 and that has column 0. And then we can put in, just like we do with arrays, any value we want. Let's say 5. And I'm gonna put in, I don't know, like 0, 1, put in 6, and so on. I'm gonna keep doing this manually to demonstrate the process. So here's 3, 2, let's make this 2, this 3. Then here we have, let's say 1, 1. So let's repeat this. 2 lines here. So these 4 lines here are going to fill the first row. These 1 here are going to fill the second row. And then the third row. And then the fourth row. Oh, I think that I made a mistake. So here we have 4, and then we need 4, and then we need 4, and then we need 4, and then another 4. So this is for the first line, this is for the second line, this is for the third line, this is for the fourth line, and this is for the 5th line. So I'm gonna change these numbers here. Let's make these, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Right, so now we have filled our entire matrix. Okay. Now, as you can see here, we kept like filling. So this should be 4. So as you can see here, we've kept filling the matrix manually. So we kept saying matrix of 0, 0 takes 5, matrix of 0, 1 takes 6, and so on, which is not practical way to fill a matrix, because as you can see here, we can notice the aspect of loops. There are instructions that are somewhat repeating. So why don't we just do them inside loops? So that's what we're gonna do exactly here to demonstrate the process of putting a bunch of values inside matrices. So I'm going to delete all of these instructions here, and then I'm going to create a loop. So let's say that we want in this loop to fill and print the first line only. Okay, so I'm going to say for int I, for I starts at 0 while I is less than 4 I++, because we're gonna print 4 columns: column 0, column 1, column 2, and column 3. Those columns that we want to print are on the first row, okay, the 0th row. So let's print f a bunch of numbers. Let's make them separated by tab, and then let's give it the matrix of the first row and the ith column. Okay, and let's try to print that. Okay, in all honesty, I am going to copy this, and I'm gonna get back the matrix that we filled earlier so that we can see the changes that we made. Here, a semicolon. And as you can see, this printed the first row. So it's 5, 6, 3, 2, okay? Now what if we want to print the second row? Let's print the second row. So that's 1, 2, 3, 4, right? Actually, I'm going to replace that I with J, or let's replace that with call. It's a better name that has more significant meaning. So call. So again, that's the second row, okay? Yeah, second row. Now let's try to print the third row. So I'm going to change that 1, 2, 2. That refers to the third element, so that's the third row. And as you can see, so that's 5, 6, 7, 8. So in order to move between rows, what we're doing actually is we're moving this number here, this first index here. So first we started it with 0, and then we moved to 1, and then we moved to 2, and for every different value we change here, we're actually printed a different line. So what if we want to print all of the lines? So actually what we have to do is to create another loop that starts from the very first line and ends at the very last line. So let's say, I don't know, for row. So let's declare row variable. And here we have for row starts at 0 while row is less than 5, because we have 5 rows in here. We increment row. So this other for loop will be inside the new row for loop, okay? So if we try to print this, if we try to execute this, as you can see, this will print the third row 5 times. So that's 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. So that's the third row 5 times. So if we want every time to print a different row, instead of printing always the third row, we're gonna print the row number row. So the rowth element we're gonna print. So let's try that. And that's what we want. So that's 5, 6, 3, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, and so on. So that's actually that's actually the matrix that we have filled, right? So that's the matrix that we have filled. Now, the only remaining thing that we want in order to present this matrix in a nice way, we want whenever we print a line, we want to jump to the next line. So after printing one line, we jump to the next line, and then we print another line, and then we jump to the next line, and then we print another line, and then we jump to the next line. So here, after completing every line, I'm going to print F a new line. So that will print a new line. So let's try that. And when I try that, as you can see, the matrix got printed the same the way I wanted. So it's 5, 6, 3, 2, 1, 2, 3, 4, and then we have 5, 6, 7, 8, and so on. That's what we want, right? So that's what we want. Here, this should be 5, okay? This should be 4, sorry. All right. So that's it. So that's the exact same matrix that we have filled in here. So that's 5, 6, 3. So it's the same matrix basically. What if we want to print the matrix like flipped, like the columns and then the column and then like not 5, 6, 3, 2. I want it to be 5, 6, 3, 2. Okay. What if we want to flip this upside down? Okay. Flip it by its diagonal. We call that the transpose in math. So the only thing you have to do is to replace these row and column. So this row becomes col, and this col becomes row. And I really do recommend that you create a matrix and keep experimenting with that. Keep playing with the indices. See what you get. Okay, try different values. And as you can see here, this is the 5, 6, 3, 2, and 5, 6, 3, 2, and then 1, 2, 3, 4, 5, then 6, 7, 8, 9, and then 10, 11, 12, 13. As you can see, there are some redundancy here because the size of the matrix is not it's not a square matrix. The row is bigger than the columns, okay? For that reason, when we flip the columns with the rows, we do not get the exact same result. But again, it's basically it's a way to experiment with matrices. So let's get this back to row and this back to column. Now instead of filling the matrix here element by element, what if we want to print the fill the matrix in loops? So as you can see here, starting from the first row, the elements that I've got here are incremented one by one. So that's 1, 2, 3, 4, 5, 6, 7. So there's a loop in there. Why don't we just write a loop instead of all of these elements? So that's what we're going to do now. We're going to replace that 16 lines of code with a couple of lines of codes that will exactly do the same job. So we're going to have to write another loop here. So I'm going to create the row variable as well as the column variable. And then the row starts, as you can see, the row starts at 1. So row starts at 1. And then the row ends at 4. So while row is less than 5 or less or equals to 4, it's basically the same thing. And then every iteration, we're going to increment the row by 1. So basically, the for loop that we have wrote here means for every line. Now for every line, we're going to deal for every column. So for column starts at, as you can see, the column always goes like this: 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and so on. So it starts at 0. And then it keeps incrementing until it hit 4, okay? So while it is strictly less than 4, we keep adding 1 to column, okay? So this is how it gets executed. So we execute the upper 4 here, the row 4 once, and then we execute this inner 4 4 times, and then we'll leave this inner 4 loop, and then we execute the outer 4 loop once again 1 time, and then we execute the inner 4 loop 4 times, and so on. So 1 4 and then 1 and then 4 and then 1 and then 4. So that's how the loop goes actually, because for every line we want to get we want to fill 4 columns. Okay, so let's access the matrix of row column. So the matrix of row column will always get a value that starts from 1 and gets incremented. It keeps increasing. So why don't we just create that variable? So it'll be a variable called counter, or whatever you want to call it, and it starts at 1. So we're always going to assign to a matrix of row call the counter variable, and we always going to increment the counter variable to move to the next value. So from 1 it jumps to 2, and then from 2 it jumps to 3, and so on. So counter plus plus. Okay, we want to increment it. Now let's see. It should print the same values here, and as you can see, it says that I have already declared the call and row. There's no need to redeclare them again. So let's now print, and as you can see, it's the exact same result as earlier. So it's 5 6 3 2. Those ones are initialized here. And then we have our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So it's the exact same result here